Hey everyone, I'm Talia and I'm a Senior Product Marketing Manager at Lightstep. Super excited to have y'all here today to talk about observability and how to keep developer velocity strong in the midst of moving towards modern distributed architectures and deploying risky changes. Before we get started, just want to jump into a few housekeeping items. This will be recorded. We'll send it out later today. Please feel free to drop any questions in the Q&A section of the Zoom UI. So like I mentioned, I'm Talia. I manage product launches here at Lightstep. Before stepping into this role, I was our first product manager and actually spent the majority of my time working on the feature that I'm here to talk to y'all about. I also have one of our engineers, Joe, and we'll pass to him.
Hi, I'm Joe. I'm a software engineer here at Lightstep. I'm one of the early employees, and I build databases. The feature you're about to see is powered by a few databases that we built specifically for this platform.
Awesome, and we will jump right in. So software has transformed our lives. It's integrated into practically every single thing we do and will only become more intertwined into our day-to-day. Because of this, we see innovations come out to help us keep up with the needs of consumers, specifically innovations that will help our software stay reliable, predictable, easy to use, while keeping development velocity high. With this type of shift, we see modernization become synonymous with things like migrating to the cloud, using Kubernetes, containerization, all technologies that also lead to drastic decomposition of monolithic architectures. This type of modernization also encourages service-oriented architectures or true distributed systems that, although solve many of the problems we're faced with monolithic architectures, create a whole set of problems of their own. So we end up in this place with deep multi-layered systems where service ownership is spread across many teams, and there are upstream and downstream dependencies that can sometimes feel like a black hole to try to understand. The benefit of these distributed systems is that teams can move faster. They can develop, deploy, and operate in autonomy. But this level of autonomy can also lead to siloing. We find that developers can be scared to deploy out of fear of not knowing how a change could potentially impact other services. They can lose confidence in aggregate performance because within a service-oriented architecture, it becomes increasingly difficult to reason about holistic performance by just looking at individual components. For example, you might have 10 services involved in an end user transaction requesting a Lyft ride, but can you really assess the performance of requesting that Lyft ride with a single number associated to a single service? Probably not. You'll need to know how every service played into that request and start viewing their performance as a shape and not just a number. When requests cross boundaries like this between services, conventional tooling completely breaks down, which is why deep systems can be highly correlated with catastrophic on-call shifts, performance mysteries, unexplained regressions, inter-team finger pointing, and an overarching lack of confidence that decelerates feature velocity and ultimately innovation. So why aren't these traditional tools built for the problems we face today? Traditional monitoring is the best way to look at a number when you know what you are monitoring and want to know exactly what happened. For example, you know that CPU increased by a certain percentage or know that a log has a certain error code. But most developers are used to staring at telemetry data day in and day out, trying to piece together a story for what happened, when it happened, and why. With metrics, developers can see correlation, not causation. Logs can be slow and extremely time-consuming to parse through, and traces, although show you a more complete picture, can also be time-consuming to parse through. And for most of these solutions, they end up being data volume based, meaning the more data you inevitably want to send to the vendor, the more you have to pay. These experiences end up being disjointed. They require context switching, constantly switching between different tabs in order to, again, paint that full story of what went wrong and why. With observability, developers don't know what they're looking for. They just want to observe. They want to observe their entire system without worry of overhead, costs, or not catching anomalies. It's the best way to find the unknown unknowns. So hopefully that resonated with you all so far, but just to drive this message home, I think you can imagine what these problems might sound like with real people. We end up with frustrated teams who are guessing how to solve a problem, waiting on tribal knowledge, or just can't find the data they're looking for altogether. So what do you actually need to solve this today? You need confident visibility across your services, your coworker services, and dependencies that impact both. You need this all in a format that surfaces significant information in an easy to use and understand way, and that's something that Lightstep can help with. So service health for deployments. We created this feature because we wanted to be able to do two things. One, catch performance catch performance regressions quickly if something went wrong, and 2, easily isolate the root cause of that regression just as quickly. So I want you to imagine this. It's a Friday afternoon and you're deploying a new version of the inventory service powering your e-commerce platform. There are some risky changes going out, so you want to make sure everything looks healthy before you leave for the weekend. On the latency chart, you can see that right after your deployment, there was a spike in latency, and you want to investigate why. After you've selected the latency spike to start investigating, you want to select a baseline to compare it to. You choose the hour before the deployment, as you can see that the latency was normal during that time. You're then able to actually compare the two periods. You start to look at the latency distributions, and you notice that the spans after the deployment are much slower. You also see that the large batch is true tag is newly correlated with high latency. Now that you've determined a tag that is correlated to high latency, you want to identify the operation that is taking the most time in that service you just deployed. Using this operations diagram to find intra-service critical path, you can see that the right cache operation is contributing the most to latency. And now, just to confirm this hypothesis that the large batch true tag is truly slower than normal, you can group the tags to show the latency for large batch true and false and see that the true has much higher latency. We can see here that within minutes, we're actually able to identify regressions that happened and what caused them. This is a feature that Lightstep is actually also using very frequently when we're doing root cause analysis, and that's why we brought Joe on today to talk about one of our latest incidents and how we actually solved it. So with that, we'll jump into a real life incident.
Thanks, Talia. So like Talia said, I'm going to talk about a real incident that we actually faced this Friday. I was on call this Friday and through the weekend, and Friday afternoon, right around 2:30 in the afternoon, I got paged for increasing error rate in one of our services. This metric mixer front end is part of the database services that my team owns and that I was on call for. And as you can see here, the error rate actually started to go up from a very healthy 0 to a maybe not so healthy 0.5. This is a pretty critical system for Lightstep, so we're pretty sensitive to any kind of errors that we see. So after I got paged for this, well, actually, Talia wanted me to talk a little bit about how I used to solve this kind of problem. Particularly at my last job, we had a log aggregator. We had a metric system where you could write really nice dashboards in code and publish them. And we had tracing. We had a Zipkin installation. And so the way that I would have approached a problem like this in the past would have been to think about who depends on me and who might call me, and go to look to see if there are any of them who are also experiencing an increase in error rate. I would jump into a Slack channel and ask people if they're seeing anything funny. I would go look at our alerts and see if there were alerts for any of those other services. And then to kind of find the cause, I would most likely jump into our logging system and start filtering on, the last 10 minutes of logs or something like that. This is a lot of tabs. This is a lot of hopping around, and would genuinely be pretty stressful. Every minute full of errors is minutes that customers are seeing problems. So on Friday, what I did was go from here straight to Lightstep's service directory. Now I have metric mixer starred because it's something that I end up going and looking at a lot. And so the first thing I did was find the operation name that was experiencing errors. In this case, that's append metric points, and selected the time range when errors were happening. I'm looking back in time right now, but at the time it was, about this time of day. So I select this to analyze regressions and go ahead and click into investigate regression. Look at the immediate past where errors weren't happening. Select that time and click compare. Now Lightstep, pulls up all of the spans involved in this operation, looks at the traces associated with them. And because I knew errors were happening here on the metric mixer, I went ahead down to the table and made sure I was selecting the regression space and filtered the spans for errors. So now I have a list of several errors that were happening at the time where I was having problems. So let's take a look at one of those spans. I'm still in the same tab here. The span that had the error is highlighted in the right-hand side. And so I scrolled down to start looking at logs. And what I saw here is this error logged here that the gRPC service received a request message that was bigger than our max accepted message size. By the way, this is something like 489 megabytes. I mean, we already accept very large messages for our database. But, this is bigger than expected. And so, what I want to find out is who's calling me with such a large message. So I find the highlighted span here that's causing an error. And I can see just up from here is the service calling that as my gRPC client, which is a service we have called Live View, which displays a bunch of different kinds of data for the user. So all in one tab here, I've gotten from I'm seeing errors to who's calling me and seeing errors. And so what I did to get fixes for this is hop in that team's channel, look for changes that they made. And what I found out on Friday was that they had made a configuration change to change the amount of data and sorts of data that they were putting in my database. So we reverted that configuration change for the time being. Errors went down, and they're working on that feature today and probably tomorrow to split that up into different requests. So we solved those error cases really fast. The thing I want to emphasize here is I went through this at just about the speed that we did today. Maybe add a minute in there for scrolling through the table and deciding to filter, but that was how fast I was able to find the cause of this problem compared to 10, 15 minutes or more with tooling that I would have had at a previous job. So I was super happy about this. I dropped a note in the team's channel who built this feature because they got me out of a stressful on-call situation like lickety split. So I was super excited. So that's my on-call story. This is why I'm excited to work at Lightstep. This is why I'm excited to build tools like this, because I've been there and I know what is up. So I'm going to hand it back to Talia to kind of finish off our webinar.
Awesome. Thanks, Joe. Like you had seen, it really took under 5 minutes for him to walk through an example of how we actually investigated a regression. That is something that we're hearing a ton across our customer base, and really why we built this feature. We wanted this to be a one-tab solution so that you don't have to jump between many different tools, many different telemetry types to figure out what has gone wrong and why. We want you to be in one place and be able to quickly see a deployment happened, what changed, and why that happened. And you can actually try this out for free in our sandbox if you go to lightstep.com/play or click this link. You can actually jump in and see the scenario for how you might investigate a performance regression after a deployment.